Hello and welcome to 2.3 and 2.4. We're going to be talking about solving multi-step equations for 2.3, and you can erase this part 2 portion of it. And we are going to be talking about 2-4, which is solving equations with variables on both sides. So our swab at is to do just that, solve multi-step equations and equations with variables on both sides. So from 2.3, I'm going to throw a little bit of fraction action and some decimals for you all. Solve the equation, choose the method you prefer. So I'm going to tell you one choice for this type of problem is to get the common denominator and simplify it, but I'm going to tell you it's going to be a little bit of a hot mess. So there is an easier way. Think about these numbers, 4, 2, and 3. 4, 2, and 3. Think about what the least common denominator would be for those, or least common multiple. If I did want to combine them all into one, what would the LCD be? Well, for those two numbers, the smallest number that they all go into is 12. So what I'm going to do is I'm going to multiply each one of these by 12. Why would I do that? Well, remember when we're multiplying by fractions, you can always just put this over 1, and then I just so happen to be a cross canceller. So I'm looking at 3 and 12, and I'm thinking, okay, what goes into 3 and 12? Well, 3. 3 goes into 3 one time. 3 goes into 12 4 times. So what would be left just from this portion right here? 4x. If I put this 12 over 1, I can still do some more cross canceling here. 2 goes into 2 one time. 2 goes into 12 6 times. So what's left? Minus 6 equals, putting this 12 over 1, 4 goes into 4 1, 4 goes into 12 3 times, 3 times 3 equals 9. Now this is a lot easier than that. That's fraction eliminating. That's what we just did. We got rid of them. Only legal because I multiplied every single term. People love to eliminate the fractions, but sometimes they skip just one term, messes up the whole answer. So we know how to solve this from previous lessons. So 4x is equal to 15 divided by 4. And x is equal to 15 over 4. Now one tip I do want to give you. If at some point you're like, whoa, what are you doing? This is too fast. You can always press pause. If at another point I'm going too slow, you can always do times 2 or kind of skip a little bit. You can also press pause when you see a problem and you feel confident, and then try to complete it by yourself and then see if your work matches up with my work. So I just showed you how to eliminate fractions. Now let's see how to eliminate decimals. So when we multiply, for example, 0.25 by 100, what we like is, because this is just a 1, because there's 2 zeros, if you remember, you just move it over 2 times. So when I'm looking at these decimals, I'm trying to figure out which power of 10, like 10, 100, 1,000, can I multiply each term by in order to get rid of the decimal. So if I multiply it just by 10, I would only move this over 1 time. Not helpful. I need to move it over twice. So what I'm going to do is multiply by 100 to each term. So if I multiply this by 100, this moves over twice, and I have 52y. Plus, this moves over twice, and I get 250, equals, this moves over twice, 510. This is user-friendly. I know how to solve these every day, all day. I'm going to go ahead, now you can press pause if you want, and do this on your own. And just check your answer with mine, or you can roll with me. I get 260 if you want to trust my math. And then I divide by 52 and divide by 52, and you can trust that I already checked that this is equal to 5. I did it in my head, if you believe that. Don't believe that. So this one looks similar to this one. There's a whole number there though, and that's kind of different. How much do I care about that? I don't. What I do care about is that there are 2 numbers after the decimal point here, 2 numbers after here. So what's the power of 10 that I need to multiply each thing by? I'm thinking 100. Now at this point, I would love for you to press pause and try to continue this problem on your own. When you are done multiplying each term by 100, solve the equation like you normally would, and then check your answer with mine. Alright, let's see if we matched up. When I multiplied by 100, I got 400n plus 24 equals 1576. I subtracted 24 on both sides. I hope that you did too. And then I got 400n equals 1552. Divided by 400, I am left with n is equal to 3.88. How do we like that? I like it. Now we have some more fractions for part D. And what I love about this actually is they already have the same common denominator. All of them. They all have a 7, and another 7. So I'm going to multiply each of these by 7 times 7 times 7 times 7. Go ahead and do that for me and press pause. See if you match. Actually, let's just do it. I get a cancel, cancel, plus 5 equals cancel, cancel, 2. Love this equation. I'll subtract 5 on both sides and get a equals negative 3. Check your sign for me there. Make sure you get negative 3. Canceling. That's what we like to do. We want to get rid of the fractions and get rid of the decimals. Not that we can't do it, because we can. It's just we're outsmarting the problem and taking an easier route. Okay, that's 2.3 in a nutshell. 2-4, we're going to look at variables on both sides of the equation, and probably won't check our answers for this one. You might just have to trust me because I don't want to make this one super duper long. So I have a Q and I have a Q. Some people were taught to always move the smaller one, and I don't know, maybe it's because I'm left-handed. I pretty much will always move my variables to the left side. I don't know why, I just do that. So this was a positive Q. So I subtracted 2Q on both sides. On the left side I have negative 3Q minus 11 equals 4. And then I'm going to solve the same way that I've done before with two-step equations by adding 11 to both sides. And I have negative 3Q equals 15 divided by negative 3. And I get Q is equal to negative 5. Equations on both sides. But what the heck, B looks way bigger than part A did. It's because we need to do a little bit of simplification first. So we learned this in chapter 1. Left side, I like it just the way that it is. I'm going to rewrite that one. The right side, however, we need to do a little bit of work. So I'm good with this 8n. That's fine. But I do need to distribute this here and here. So negative 3 times n is negative 3n. Negative 3 times negative 4 is plus 12. I can still do a little bit more work. So 14 plus 3n. Notice I'm going to simplify as much as I can first. So 8n minus 3n is 5n plus 12. Now this I can deal with. I don't need to simplify anything and there's no tricks waiting for me. So I'm going to go ahead and subtract 5n. And subtract 5n. Notice, minus that little mistake there, notice I'm going to put the like terms right underneath each other so that I can see, oh, okay, these cancel out. This 14, I haven't done anything with it, so I'm bringing that down. 3n minus 5n. What's 3 minus 5? Negative 2, and I'm going to keep the n equals 12. Now I want to get that variable by itself. I want to isolate it, so I'm going to subtract 14 on both sides. And I have negative 2n is equal to negative 2. Would you agree? And then I'll divide by negative 2 on both sides, and I get n is equal to the number 1. Gorgeous. If you need to, go ahead and press pause now. So just double check your work. Make sure you have what I have, that your notes are nice and complete for me. And then we will look at C and D. Not a huge thing, but there is something that kind of slipped in here at you. So what's my first step that I want to do? Say it out loud. Say it out loud. Very good. I am first going to distribute this 2j here and then here. So negative 2, excuse me, there's negative 2 here and here. Negative 2 times j, negative 2j. I did a little bit of a spoiler alert. And then negative 2 times negative 3, I get plus 6 is equal to negative 2j plus 6. Okay, twinning. These are the same exact thing. They are identical. If you know identical twins, identical. Oh, so instead of saying identical though, I'm going to call this the identity. So some people will just leave that as their answer. Truthfully, if I ask you what the solution for j is, j can be anything. So we're going to say all real numbers. Because no matter what I put in for j, it's going to work every single time. So all real numbers. This was actually a mistake. I didn't mean to make that fancy A. Alright, that's one trick that you might see. So if you did carry this out and you did, okay, plus 2j, plus 2j, you would get 6 equals 6. Well, when does 6 equal 6? Every day, all day. When? For all real numbers. Okay, for part D, let's try it. I would, if I were you and I was feeling confident, I would press pause right about now and then try this problem by yourself and then see if you land where I land. Or you can roll with me and I get negative 3z minus 6. Okay, let's take this one step because they almost look like twins but not quite. So I'm going to go ahead and add 3z and add 3z. Scoot this over, make sure you can see me. And I get these cancel out. Negative 4 equals, oh wait a minute, these cancel out. Negative 6. Hold up. Not the same as what I just did in the pink one, because this is not negative 6 equals negative 6. This is negative 4 equals negative 6. Is that true? Never. Never. So no solution. There's no value of z that I can put in there that's going to ever make negative 4 equal negative 6. There's no variable attached. So no solution. This is what no solution looks like. This is what identity looks like. If you get the same number equals the same number, all real numbers, all day. All right, problem solving, everybody's favorite. I know it, but we're going to ease our way into this. So 3 times, when I look at a word problem, I like to first kind of either highlight or underline important things. So 3 times seems important to me. 3 times what? 3 times the sum of a number and 4. Okay, this is telling me to multiply in my head. Sum is telling me to add. And then the word is, I know that means equals, is what? 8 less than half a number. Okay, what do I want my number to be? Let's go basic and let's just call it x. Ooh, even though we have this x there. 3 times the sum of a number, that's my x, in half of a number. Okay, let's translate now. 3 times what? The sum. So because this is a sum we're talking about, I'm going to go ahead and put this in parentheses for this sum. The sum of what? The sum of a number, I'm calling it x and 4. 3 times the sum of a number, x and 4, is 8 less than means subtract, but because it's less than, that means I have to switch the order. So it's going to be something minus 8 and then half of a number. It's delightful. So I have 3x plus 12 is equal to 1/2 x minus 8. Fractions, fractions, fractions. I can get rid of them right now. I'm going to multiply by 2 times 2 times 2 times 2 times 2. 2 times 3x is 6x. 2 times 12, 24, equals, cancel, cancel, x. And then 8 times 2 minus 16. You are welcome for the sound effects. I'll subtract x from both sides and get 5x plus 24 equals negative 16. Minus 24 minus 24. I'm going to carry on over here. 5x is equal to negative 40. Negative 40. Sorry, it looks a little sloppy. So divide by 5, and so x is equal to negative 8. Okay, perfect. So for this next one, I'm going to help you with the setup, and then I'm going to have you solve it. A movie club charges a one-time movie fee, membership fee of $25, which allows people to purchase movies for $7 each. Another club does not charge a membership fee, but sells movies for $12 each. How many movies must a member purchase in order for the cost of the two clubs to be equal? Okay, so the first one I'm going to pay $25 plus $7 each for each what? Each movie. So I'm going to call that X equals, the other one there's no membership fee, so it's just 12 times X. Alright, my people, go ahead, take a moment, press pause, and solve this one. Okay, I switched it up a little bit because I brought the 7x over here, but either way, you get x equals 5. So after purchasing 5 movies, the amounts will be equal. Alright, beautiful people, thank you so much for joining me, and I will catch you next time. Thanks.